Yeah, so to start off, I know it's been a week. If anyone has any leftover questions from last week, it would be a good time to ask it now as we just wait for last student or two to join us.
What
As a
did
reminder,
we do last week? I wasn't here.
great question. We did several things last week. See someone talking about the vaccine. Yeah, my second dose was not fun, but don't worry, you'll be fine.
The recording, post the recording on the Google Classroom as well, yeah.
All right, so in terms of last week, I think from what I remember, we went over the revolve tool. So that's the second one here. I think we'll be using it today. So when I get to that, I'll make sure to explain that pretty well. The other thing was assemblies. So we made this little brick together as a group demonstration thing. And we learned our first steps in making an assembly, including how to fasten things, how to fix your first part to the assembly space. And the only thing we really touched here was the fasten mate. So we will also use that today, hopefully, depending on what we get through. So I guess when we get to it, we'll get to it, and I'll make sure to take it slow. Seems like this is everyone we're gonna get, so let's get started. I said last week, of these projects that have been done in previous versions of this class, I believe this sprocket handle thing has been one of them, and quite conveniently, each of you hopefully have completed a sprocket from a previous week. So hopefully you still have this model. Let me know if you don't. I'm not really sure what you'd do without it, but we'll figure something out. And what I'll say is open up that Part Studio, that document where you had that sprocket made, and just start working. When we start doing stuff today, just create new Part Studios inside of this document. Like so, with the plus sign, create Part Studio, and just make new parts all in this same place where the sprocket is. It'll make things a bit easier later on when we get to assembly, just to have the stuff we're assembling together in the same place. So with that, I'll give you a moment to log into Onshape if you have not, and open up your sprockets, and to raise issues if you have them. All right, so hopefully you're all good now. So let's take a look at what the people who designed this sprocket stand were doing. So when you're trying to design something, sometimes you'll be, and speaking generally, of course, like as a designer, as a hobby modeler, and potentially 3D printer, you'll often find yourself in a position where you're trying to make something, right? I hope these are a copy of the slides, but it's fine. Okay, so we just open a little text document here. I hope you can all see the notepad. So in this case, we're not designing something entirely from scratch. We kind of have an idea of what we want, and that's a little stand for a sprocket with a handle that you can crank to turn the sprocket. And our final goal is a model, something in the ballpark of this, where everything moves. You can click and drag on it to make it move. You can animate it. And that's kind of what we're working towards. So we know what we want. And so how do we get there? So when we're modeling, we need to kind of think about what we need to make. Every assembly is made up of parts. And so we know what parts we need. We can see them all here. And I'll give you a second just to brainstorm what are the things that we're going to have to design to model so that we can put it into an assembly. So the first thing is the sprocket. So I'll just write that to begin with. What else do you see here?
A spherish type thing.
I might want you to be a bit more specific than that. Which part are you referring to? Like the
Yeah.
knob here? Okay, so like a handle, right?
But you don't really like hold on to that though.
I guess it depends. But some kind of handle, I suppose, like a handle. Okay, what else do you see? That's a good start.
I see a stand kind of thing.
Yeah, so this kind of U-shaped, the square thing that's supporting the sprocket, right?
Yeah.
Right. That's definitely there. Okay, what else do you see?
A cylinder that goes through like the middle hole of the sprocket.
Yeah, cylinder. We might call it an axle or a shaft or something along those lines. But we do need some probably cylindrical component that'll rotate and it'll keep the sprocket on it. And there might be one more depending on how you design this thing. Maybe I'll just call it out since it's the last important thing. It's kind of a linkage where between this handle, if you can see my mouse cursor, and between that handle and the axle, you see they're kind of offset from each other. They're not collinear. So you need another member here. They'll give you a bit of leverage so you can kind of do this circular motion to produce a rotation in the axle. And so these are all our parts we need. Once we have these, we can pretty much assemble it together. There are some details here. If you look really closely, you can see that the designer of this particular assembly made a keyway. If you don't know what I'm talking about. They have this kind of key system where the shaft has a square hole in it and the sprocket has a square hole in it. And that's how you transfer the rotation. But we don't really need to worry about that. We will find that we can kind of pretend it's there using assembly tools. And we're not too concerned about making this super accurate. So now we have a list of parts. So we need perhaps 4 more things on top of the sprocket we already have. And so let's get started. I'll start off by naming my part studio so I don't get confused. First one is the sprocket that we already have. Everyone already has. Next, I want an axle.
How do you recreate a studio?
Sorry, your voice cut out.
Oh, how do you create a part studio?
Right, so hopefully you're already opening, are you inside of this document with your old sprocket in it?
Yep.
So in the bottom left corner, you'll see there's a plus sign. If you hover it, it says insert new element. And if you click on it, you can see in the second group of items, the first option is to create a part studio. You can just click it, it'll take you there. Yeah. And to rename it, just right click on the tab in your bottom bar. And there's an option to rename it. So I'll just go ahead and create all my part studios. Let's see, the stand, handle, and I want a linkage of some kind. And so before we start, I just want to, as usual, I know that I have like an extra challenge for those of you who are fast, pick up things really quickly and get bored. This time it won't be a different thing. It's just that I'll probably demonstrate a pretty simple version of each of these parts. And if you want to increase the complexity, add some more details, you can see the linkage maybe. Well, I thought it was pocketed, but that's just the lines on it. You might add some details there and so on. So that's what you can do. If you really want to share your stand at the end of all this, I'll make some time at the end, but let's get started. So first things first, I need the stand, right? So I'll start off with the same question I asked before, like what shapes do you see? When you look at just the stand part that's holding up the axle.
A triangle.
Okay, someone says triangle. I'm imagining you refer to this part here, where kind
Yeah.
of like tapers, yeah. So we do need to achieve that kind of taper somehow.
And like it's kind of a rectangle too.
Yeah, when you look at it like head on, like the upright parts are here, you definitely see a rectangle going on. And so given that, what would be a good way to start doing this? What 3D features might you use? Of the ones we've learned, I suppose. Not too many. Extrude, revolve, fillet, chamfer, shell. No ideas.
Wait, can shell like go through like two sides? Like if you
Yeah,
shell both the front and the back.
yeah. So the shell can actually take multiple faces, which is pretty cool. If you want to get a better intuition for it, I'd recommend that you play around with it yourself, but just to do an extremely fast demo. If you do pick two faces for your shell, this and this, you do end up with something like that. So if I pick this third face, I'd end up with something like that. So maybe that gives you an idea or two of something we can do. But I'm getting ahead of myself. So here's some ideas. As I go through these demos, you're free to try things on your own. Try to make the thing beat me to it, if you will, or just follow along. Either way is fine. I'll just start out by making a sketch, maybe in my front plane. And I'm going to kind of start with this, someone said like triangular shape. So this tapered face. My plan here, my game plan is to draw that in a sketch, extrude it out, and then maybe I'll use a shell, like someone suggested, on this outer part just to make it hollow. And we'll see how it looks from there. So start off my old line tool. I have a line. That's kind of the base. That's where the ground is. I know I need a circle because that's where the axle goes through. And I probably want another circle, one for the inner diameter, one for the outer diameter. Then I'm gonna have some lines. Go something like that. All right, so nothing's defined right now. All I did was draw some shapes to get something like that. You can see that everything's very unconstrained, underdefined, totally free to move, but the basic shape is there. So now as we start to dimension things and define things, the question comes up, how big do I make it? Well, the answer to that is how big is my sprocket? And I can go back here. If I want to find out how big something is, I forget if I showed this to this class, but you can see in the bottom right, there's a measure tool, looks like a tape measure. And so I can do a simple point-to-point measurement like that. And it tells me the distance is 3 1/4 inches. Another thing I could have done was just go into the sketch and just look at the circles that I drew. And so I can see that 3 1/4 inches is the maximum diameter of this thing. So I need to make sure that my part will clear, right? I don't want the sprocket to be so big that it can't fit inside of the stand. And I don't want the stand to be so big that it looks silly. So I'll start off, the critical dimension that's relevant to is kind of this one. So again, if I ever do things too fast or you can't follow, just interrupt me, ask a question. I made a dimension like I've done before. I select the point that's the center of the circle, and I select this line, and I just drag it out to a vertical dimension. And the diameter of the sprocket was 3¼ inches, so maybe the total height can just be 2 inches and it'll look okay.
Says on mine an entity cannot be dimensioned to itself.
So what you probably did was you clicked the same thing twice. If I click something like that, you can see I get that error message. Just what I'd recommend is just deselect your tool, reselect it, try again. You have to be pretty careful with where you click, just because it can be finicky like that. And remember that your sprocket might be completely different size than mine. So just measure yours, take a look at how big it is, and adjust your dimensions accordingly. Make something up. You know, I'm not making a standardized one and only stand here. So next thing is I'm going to have this hole for the axle. And so how big do I make that hole? Well, the sprocket already has a hole, so they should probably be the same size, just so the same axle can go through both of them. So using the same process, I'll use my measuring tool. I can just select that face to measure it. I see that it's 1/2 inch in diameter. You should probably measure yours and see what your dimension should be. Seem to be in a bit of a thunderstorm where I am, so hopefully I don't have any problems with the internet. So there's my dimension. And if I think about what I'm doing here, those are pretty much the only critical dimensions here. Everything else is kind of free to be whatever I want. So I can do whatever I want now. And so as I start trying to dimension my sketch and fully define it, remember that my objective is to turn all of these blue entities, all these blue lines and such black. And a good way you can kind of figure out what's wrong, what I need to change, is to drag the blue things around and see what's still changing. So one of the first things I noticed is that this outer circle, the one that I've highlighted, its size isn't fixed. So I can take care of that pretty quickly just by adding a number. Okay, what else is, everything's still blue, so I'll drag some more blue stuff around and see what happens. I can see that the position of the center of the circle is not dimensioned yet. So I'll do that again with the dimension tool. I click a point, move my mouse over so that I get the dimension that I want. Wonder what would look good. 0.75 maybe. Why not? We can change it later. You can see just like that, a lot of things turn black because these circles, now their sizes and their locations have been fully defined. So they turn black. And so what's left? I see these points are still blue. So let's see what freedom they still have. I can drag them around and you can see they can still move around the circle. Well, what's my objective here? I kind of want the stand, yeah.
I define the circles, but they're still not black.
Are there positions defined?
Yeah.
Both horizontally and vertically?
Oh, I forgot one.
Yep, so whenever you run into that, try dragging the blue points around, and if it moves, it'll tell you kind of what's up. And so my design intent here maybe is to have a smooth stand. So I don't want this sharp corner here where the straight part turns into the round part. I kind of want a smooth transition. And so for that, I'll use my tangent constraint. And that just takes an arc and a line. You can see just by doing that, now it's a smooth transition. The straight line and the arc blend together. So that's good. And I'm still not done. One more blue line. So let's try moving it around. I can see that the width of my base is not defined anymore. And so there's a few ways I can go about this too. One thing I can do is just add a dimension to this bottom here, and that'll finish it. Another thing, maybe I don't want to think about what number I have to type there. My intent here is kind of to make this symmetrical when I look at it this way, right? For the left and right, I want it to be even. So another thing I can do is just add a constraint. It can be an equal constraint and just make these two lines equal. And having done that, you can see everything is dimensioned, everything is defined. I'm pretty much done. So I'll pause for a moment here just to see if you have any questions.
I still can't get two lines to become black.
Right, I see.
Oh,
I
I
guess-
can't get the two lines to become black.
Yeah, someone said something about the two lines. For those, it kind of depends on what you do. In my case, what I did was I created a tangent made between the line and the circle. And I made the two lines equal to each other. And geometrically, that's enough to fully define it. I guess if you still have blue things, try dragging the blue things around and seeing what happens. Someone's asking about the equal constraint, so I'll just show that again. So I started out with the tangent one, just because my intent is for this junction to be smooth. So the way tangent works is just I select the tool, I select a circular arc, like a circle, and I select a line. So I select two things, this and this. Then for the equal constraint, I select that, and I select two things that I want to be equal. So what I did there, I clicked the equal constraint, I clicked one of these lines, and I clicked the other line. If you still have a question, please ask again. I guess if you don't have the question anymore, please say that you don't. Still not turning black, interesting. Are all of your heights and centers so everything's defined. If everything is defined, that means everything is black. I guess what happens if everything is not black, what happens when you try to drag something that's blue
How do
around?
you use the equal?
Yeah, so when it comes to equal, you select the constraint and you select two entities, right? So let's say I'm in a situation like this where my lines are not equal. I can select the tool, select a line, and select another line. So just select two things and that's how it goes.
Can't get the equal to work.
There's also other things you can do. If you still have blue lines, try different dimensions. You don't have to
I
do
only
it.
have the right one
I'd say drag things around, try to see if you can figure it out. I have a lot of faith that you're able to figure it out. For the moment, if you have a shape like this that's extrudable, just go ahead with the demo, just extrude it while it's still blue. And later on, when we take a pause, I can ask you to screen share. And in the meantime, if you figure it out, that's great. So hopefully everyone has at least a shape, something like this, whether or not it's fully defined yet. And at this point, I'll resolve my sketch and I'll have my profile. So next thing I want to do is extrude it. So we've done this many times now. You select regions. In my case, due to the way that I made my sketch, I have kind of two regions that I want. I have this sort of trapezoid of sorts, and I have this. So I select the regions I want. This is what I want as my shape. As for how deep to extrude it. Again, I can see there is not much clearance issue there. It just needs to be thicker than the sprocket. So just to check how thick my sprocket is, it's 1/4 inch. So the entire thickness of the material of the stand and the sprocket thickness, and maybe a bit extra, is what I need. So perhaps I want like a 1/4 inch thick stand. In that case, it needs to be at least 3/4 of an inch. So I'll just round that up to an inch. So I have shaped something like this. Hopefully that part wasn't too bad. And the last thing I'll do is to cut away the middle part so that there's space for the sprocket to go inside. And so someone earlier suggested using the shell tool, which I believe we covered last week. And so for the thickness, in my mind, I was thinking a 1/4 inch. It's the same thickness as the sprocket. And for the faces, I'll just select and now you can see something unexpected happens. I thought it would just open up like this, but when you think about it, this hole actually creates another restriction where you can't actually break into that without breaking into the wall, which is how the shell tool works. And so that's a pretty simple fix. All I have to do is go back into my extrusion. And I actually want to also extrude this part. And now that that hole is out of the way, hopefully it'll just let me shell like that. And it does, so that's great. I'll bump the thickness up to 1/4 inch again. And I can put the hole back in just by doing another extrusion. So to do that, I'll reveal the sketch using the eye, which we've talked about. And I can create an extrusion, select this circle, change the type from add to remove. So I don't remember if we've shown this explicitly. I think we have for the sprocket. So you should be familiar with that. And just to be safe, I'll make it through all. How did I extrude the hole? So are you able to see your sketch that you drew that has that circle in it? I know someone before had a problem where they were looking at it through the part, so it looked like these dashed lines. So you might not be able to select it if you do that, but turn it around so that you see solid lines on your sketch and not like the dashed lines. Then you get your extrude tool. You want to change the second bar here from new or add to remove. So you need to have this set to remove. You select the circle. You can see by default, it kind of tries to go into the positive direction. So I'll flip it using this arrow, the opposite direction arrow. And by default, it happens to pass through the whole thing, but this is, I guess, optional. I'll change it to like something like up to next or through all. And that's just in case I update it later to be even wider. So hopefully that worked. If that worked, please let me know. And I'll hide my sketch again. So for those of you who weren't able to create this first sketch and fully dimension it, I guess right now I'll quickly take a look. Whoever it was, share your screen, please. If you still have the problem. If you don't, also
I
let
got
me
it
know.
to work.
Great, I believed in you all along. So this is our stand pretty much done now. You know, looking at it now, it does seem a bit thick, so maybe I'll change the shell to be a bit thinner. Maybe I like that a bit better. in terms of proportions, and I can always change it because thanks to our parametric modeling. So that's the stand. Next, let's go for maybe something more interesting, the handle. So someone referred to this as the sphere thing. And so we do want to have this kind of interesting shape, right? It's pretty cool geometry. You see this in real life when you have crank handles, maybe on like a lathe or similar application. We want those ergonomics, right? So someone referred to this as like a sphere thing, right? So what features might you use to try to create this handle shape? Which of these tools would be well suited to
I have
create?
one more question about the stand.
All right.
Oh, how did you get the holes in? I tried to do the extrude, but it didn't work.
Are you talking about these holes?
Yeah.
So if you're doing the extrude cut, I guess common things that might be happening, make sure you change this option to remove, make sure the direction of the extrusion is correct. So it actually goes through the part rather than into nowhere. And make sure the extent is far enough. So through all will pretty much always work. If it's blind, maybe it's too short. Like you might not see anything if you do something like that. So make sure it's through all. Merge scope should be part 1 if that should be by default selected, but
Okay.
did that work?
Yep.
Great. And so would you like to answer my question on how you would create this handle? I guess you were not here when we talked about a tool that would be very helpful for this, actually.
Yeah, I wasn't there.
Well, I see next on my Zoom interface, there is Tony. Would you like to volunteer?
This
What would you use to make this handle?
revolve maybe.
Great. What a great answer. That is my exact thought. And someone says fillet, and that'll also come into play. It's very satisfying, very smooth shape. So that should be fun to make. So I'll start off maybe with a circle. I know at the beginning someone called it like a sphere thing. So what better way to start than a circle? I'll draw something just like that. Maybe that was a bit quick, but what I do when I do these things by habit is just hovering over, so I get my constraints. You can see the vertical thing shows up and the origin highlights when I hover. But also I'm going to need a axis of revolution, so I might as well make that too. So I want a vertical line, that'll be my revolution axis. I want a circle to be kind of the tip of my handle. And then let's look what we have here. It's very interesting, kind of like tapers towards the middle and then comes out on both ends. So at the base, I can imagine I kind of need a bit of material there. Maybe between these two. I might try to use this arc tool. I think I showed this in one of the first classes, but we may not have had the occasion to use it. So now we do. You can also use any of these types of arcs, but I'll go with the 3-point arc. And the way the 3-point arc works is you select a starting point, you select an ending point. You can see I missed my ending point. So I'll try again. And I pick a 3rd point that's on the arc. So I'll just click somewhere in the middle. You can see this is kind of the shape that I've got going. And with this, I'll just start dimensioning, keeping in mind that my whole sprocket is 3¼ inches in diameter. maybe a nice proportioned length for this would be, say, like an inch. So I'll just go through, do the same thing I use. That same issue where this arc naturally tends to just create a sharp angle. And so to get rid of that, I'll use my tangent constraint again. And surprise, it also works with 2 circular arcs. Very convenient. You can see it's still blue. Let's see what's wrong. I can see it's kind of the radius of the curvature that's not defined. So I'll just select that arc as my dimension. And you can see, having done that, everything turns black. So a couple of tools that we haven't used much, but hopefully still straightforward. Once you're there, resolve the sketch. If you're not quite done, but you have the general shape, it's fine to just leave it underdefined for now. And you can always go back and think about it. So this is the new tool that we talked about last week, for those of you who were absent. It's called Revolve, and you'll see what it does when I do it. But it needs 2 inputs, essentially. One is the region to revolve. So that's similar to the extrude, where you're selecting an area that you sketched out. And the second thing is the revolve axis. So what the revolve does is it sweeps a profile about a line. And hopefully it works. Unfortunately, it does not work. And I expect that's probably because the profile kind of goes through itself. Yeah, that's what it's saying. So as usual, we're gonna have to make some changes on the fly. This should be a pretty easy fix though. Since the profile would have been self-intersecting, all I have to do is kind of close off this profile. You can imagine what Onshape might not have liked is, as it was trying to generate this model, it had this other half of the sphere that it was kind of trying to push through itself. So all I did was I add this segment here, which will close this out, make it a separate profile. And hopefully with that, Onshape will allow me to do what I want. There we go. So thankfully, now we're good. And for those of you who are seeing Revolve for the first time, hopefully this gives you an idea of what it does. You take a profile and you spin it around, and the enclosed area, the enclosed volume is what becomes your part. So you can still see my sketch in the middle there. It kind of just sweeps around. And there you go, that's my handle. It's a bit thin towards the middle there. If I don't like that.
Can you show me how to do it again? I didn't get that.
Yeah, the Revolve tool. So make sure you partition your sketch just
I
so
mean, like with the circle.
your voice cuts out. But I'm gonna guess you're talking about the sketch.
Yeah.
All I did was I added a line. So from here to here, I closed off half of the profile by drawing a line from here, a vertical line to be clear. It has to be vertical, and they'll close off your profile. And unfortunately, Onshape forgot that I wanted that profile. Just remind it. But there you go. So next thing we're going to need, I think would make sense, is the axle. This should hopefully be extremely fast. As someone pointed out, it's just a cylinder. So all we need to know is the diameter here, which I've already measured. It's 0.5 for me. So I'm just going to make a cylinder, which you may all be familiar with. I draw a circle, give it a dimension, and I extrude it. And how long should I make this thing? Well, let me go back to my stand. How wide is the stand? From here to here, OnShape says it is 1 inch. So I do want it to be a bit longer than that, to come out a bit. Maybe I'll make it 1 3/4. Maybe even 2 inches. But axle, hopefully very straightforward. These circles for this axle, I presume you're asking, should be the same diameter as the inside of your sprocket here. We just want it to fit nicely inside. So in my case, this was 1/2 inch. Yours might be different. All right, last part. Let's see if we can get through in this class.
Wait, I have a question about the stand.
Sure.
So my stand, like the place where the sprocket should be, like
Here.
like there's something like blocking the sprocket. Like the two circles at the top. Yeah, there's like a cylinder thing.
Okay, I think that's the problem that I ran into as well. To explain what's happening, I guess something like this is what you mean.
Yeah, I tried shelling the top, but it didn't work.
Yeah, so the way the shell tool works is it kind of digs into the material until it reaches a minimum wall thickness, and then it does whatever it can to preserve that. And so if you have the hole first, then OnShape needs to preserve a wall thickness relative to this hole, if that makes sense. So it needs to preserve all of this wall thickness here, even in the bottom. And so it won't shell that. And so the way to get around that is in your first extrusion, just also extrude that hole out. So it's a solid block. Then you shell it. And since the holes aren't there, it'll let you shell the whole thing out.
Oh,
And then you can extrude the hole again using what you probably know how to do. See the chat. When I did the revolve, your thing disappeared. That probably means it hasn't resolved, so it'll fail, like it'll turn red when you try to click the check mark. Did you make sure that you did not select the self-intersecting region? So so for the revolve, make sure that you're just selecting half of it. So don't select this, don't select that one, but only select these two. The stand, you can't extrude the empty hole. Are you talking about for the axle? I'm guessing. I guess common things that it might be, make sure it's set to remove. Make sure that you're clicking the sketch from the correct side. So you can see when the sketch is made visible. On this side, I can actually see the sketch with solid lines. If I'm looking at it from behind, if I'm looking at it through something, it's a dashed line, so I can't select it. And you fill the hole to fix the shell. Oh, okay. So I imagine you might be back here, and you're saying that you can't select that region. I can't imagine. It's almost certainly going to be a sketch region just because it's a circle. So try clicking on it. It might take a second to register. Just make sure to click on all 3 regions. Okay, cool. I'm not sure what you mean by it's not letting you click on the arc. If it's an issue with fully dimensioning the sketch, just don't worry about it for now. I'd rather you get through to the next parts and we can work through dimensioning stuff later. If you have something that looks like this, that's all you really need.
It won't, in the revolve, it won't let me click on the arc, like selecting it.
So what you're trying to do is you're selecting a profile rather than a line. So you don't want to click on the arc, but rather on the region, the semicircle, so to speak. So
Oh.
you do want to click on this, and if you just click on that, you'll get a sphere.
Oh, it still disappears when I do it, and I put the line in too.
Is it only selecting half of the circle, like when you highlight it here?
Yeah.
Did you select your edge? Did you select the correct revolve axis? So it's just gonna be that vertical line through the center.
Yeah. It's right.
So this might be an issue where it does matter. You need to make sure the axis is actually vertical, just because of the way that we made the sketch. Maybe that's not the issue. If you have a revolve axis selected and all of the profiles are both closed and all on one side of the axis, then it should work. I might just take a look. Do you want a screen share? Oops.
Hold on. It's like when I click on this side and then I click the check mark, it disappears.
So open up that revolve again. Can you deselect your parameters? So just click little X's in the boxes and the other one. Yeah, just to make sure we pick the right things. Right, so I see what you did there. Your revolve axis was the arc. So you want to pick the vertical line as your revolve axis. So select your profiles.
What?
Select your profiles. Click on the, so it's change your parameters to the faces and sketch regions. Right now you're on revolve axis. So click on faces and sketch regions to revolve. It's the box right above that one. Yeah, click on that. And now click on the profiles, which is the semicircle and also the trapezoid sort of thing.
Which one?
Okay, so I think, can you let me screen share again? So what you have going on, make sure your sketch is, make sure you have this line here, and make sure you have this line here. It seems like you didn't close this bottom profile.
Oh, okay.
That's the first thing. The second thing is for your revolve axis here, you seem to have selected this arc, which isn't, like Onshape takes it, but it's probably not an acceptable arc just because it's not straight. So you need to pick this vertical line as your revolve axis.
All right.
And that's because you're revolving it around. It's like you're spinning it on a spit, and that spit is your line. So I'll let you work through that. Last thing we need is this linkage here. So all this is like a bar with 2 circles at the ends of it. So I'll just quickly sketch that out. I'll start out with 2 circles that are vertical with respect to each other. I know one of them is going to have to go on over the axle, so I might make that the bottom one. So this is the essential shape. Something like that. So as you've been doing, just go through, dimension these. For the inner diameter hole, make it the same diameter you've been using for your axle, the sprocket inner diameter. In my case, 1/2 inch. For the outer diameter, can be anything. For this top circle, I want it to pair up well with my handle. So here I have a certain diameter. Try to measure what it is. It's 1/4 inch in my case. So up here, I'll make it the same. For the total length of it, I know my handle is maybe like 1 1.25 inches, maybe 1 1/8 long. So just to keep the proportions. I guess this whole thing isn't going to look very proportional at all. Mine will look a bit silly, but that's how it is. As we've done, just tangent mate. And
I
once it,
fixed the axle.
all right, nice.
I mean the handle.
That's good. Yeah. So yeah, last class we did go over a few revolve examples. Might be worth watching that one if it's posted. Should be on the Google Classroom. And it also goes over the beginning of the assembly stuff. So unfortunately, it looks like the time's running a bit late, so we might not get to assembling this thing today, but that's also fine. Just next week, be ready to assemble all of this, but hopefully we can finish the last part, which is this linkage. So I put together a pretty quick sketch there. I know some of you probably have made it, maybe not. Essentially just a few circles and some tangent lines. All right, there we go. For the sake of simplicity, I'll just do a simple extrusion and call it a day. And at this point, I'm pretty much done with all my parts. With the time we have, I'm not sure if it's worth starting putting things into the assembly. I guess I might go over like the very basics for those of you who missed it, but I'll pause just for those of you who still have questions on the 4 new parts that we created today. All right, if not, I guess quick crash course on assemblies. If you look in the bottom, by default, you'll have a tab that's called assembly. It's in the same place as all your part studios. If it doesn't exist for some reason, go in here, same way you create a part studio, you can create an assembly. It's a second option in this second group, but when you go in it, you'll see you have different tools, things look different. I still have kind of an analog to my feature tree. I have something called mate features. And all of these are my mates. So the way you put things into the assembly, just like you kind of start a part with a sketch, start assemblies with parts. You have your insert tool in the top left, and by default, it'll look for parts that are in the same document. And that's why I had you do all of this in the same document as the original sprocket, and I had to do all the parts in the same document. And that's because it's really easy now just to see everything that I made here. If you happen to not do that, there is a way to still find it in other documents, but it is a bit slightly more involved, so hopefully no one has that issue. And so the way you insert parts, as we went over before, when you're in this insert menu, you can click on a part to select it, and Onshape will bring it in to this assembly space for you. So it'll follow your mouse. All I do is click once, and that brings it in. I do want one of each of these parts, so I'll do the same thing, just click and place, click and place. And it's really when I start putting things into assemblies where I can see multiple parts side by side, where you start getting a sense for the scale. So already I'm seeing that this is a bit ridiculous. The handle looks really small. The linkage and the axle look really big, but that's how it is sometimes. Hopefully the stand looks about the right size, which, you know, that's reasonable. Might be on the small side. Yeah, actually very close, but that's fine. So once you bring all the parts you want into the assembly, just like that, click and click, you want to click this green check mark, and that will kind of resolve that whole interaction. And now my parts are all in the assembly together. You can see them. And you can also see that I can freely move them around. So none of them are constrained. None of them have any relative motion with respect to each other. They can just do whatever they want, go anywhere, do anything, and so on. And so I guess over the next week, for those of you who have already had some practice with assemblies, maybe you want to challenge yourself and just assemble this on your own, go for it. You might have to look up what some of these mates work, but there's a lot of information out there if you just search for like Onshape Revolute mate. There's probably illustrated guides on and videos on how to use them. So for the curious, for the bold, that is an option. But next class, when we get back, I'll probably start off just by assembling this together. And for those of you who missed last class, maybe take a look at that part just to see how the fasten mate works and how mate connectors work. By the plan for next week, I was probably going to try doing this kinematic machine here. We might still do that next class. And at some point, we'll talk about 3D printers and slicers. But this is only week 5. I guess it's already week 5, I believe. All right, so last minute questions. The floor is open. Otherwise, that's all we've got. And if there are no questions, just hold on to your Onshape documents. Maybe learn something. I'll see you next week.
Wait, how do you rotate your shapes?
Do you mean revolution feature or?
Like just like make that sideways. Like the
In the
hand
assembly?
or like any of the parts.
So
Yeah.
if you click on them once, you'll have this like motion tree of sorts pop up. Do you see that?
Yeah.
Yeah, so we saw a similar kind of like motion tree when we were doing sketch features. And so it's the same way it works. You can drag things around with these arrows. You can also rotate them using these little handles. It's being a bit finicky. You might have to type in a number. Yeah, like that. So you do have complete control over how to move them, but you probably want to create a mate, which is a more exact definition of how things move relative to each other. So not to spoil it too much, but it's going to be a revolute mate for at least one of them. All right, anything else? Well, goodbye then.